Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Internal Xsum Whisper Loop by Yitrio. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Next, we have to draw a one cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So the one cell wide loop of orthogonally connected cells means that to connect, you have to share an edge with two other cells on the loop, and two and only two other cells on the loop. And you cannot also touch any other cell besides those two cells on the loop. So for example, let's see what would be a valid loop here. This would be a valid loop here. However, let's see what would be an invalid loop here. Well, something like this would be invalid because it's not every cell on the loop is shares an edge with two other cells, two and only two other cells on the loop, right? This shares a edge with one, and this shares a edge with only one. What else can we do here? What if we have something along the lines? So this is not a valid loop. Hold on. Let's go this way. This, oh, okay. This is also not a valid loop because these two cells touch each other diagonally. So in addition to that, each cell on the loop has to share an edge with two and only two other cells on the loop. You cannot have them touching diagonally either, anywhere. So that's how the loop works. The loop acts as a German whisper line. That is, adjacent digits on the loop must have a difference of at least 5. So if we had our valid loop, we're going to change it, I guess, a little bit. That would mean that if this were a 3, this would have to be an 8 or a 9, because those are the only digits. The only digits which can be 5 or more away from the 3 are 8 and 9. Hence, you know this digit has to be 8 or 9, and this digit has to be 8 or 9. Because the loop, again, acts as a German whispers line. Okay, and the final rule is cells with an arrow clue act as internal loop xsum clues, where a digit in a clued cell, so in like this cell, indicates the sum of the first x digits on the loop in the indicated direction. Okay, so that's not helpful here. Where x is the digit in the first loop cell in that direction, not including the clued cell itself. X cannot be larger than the number of loop cells in the indicated direction, and the clued cell may or may not be on the loop. Okay, so all these arrows, first of all, they could or they could not be on the loop. We don't know. And then let's see, how do we... So the digit is a sum, right? So this is the sum of all of the first x digits on the loop in the indicated direction. Okay, so let's say, let's change this loop to be this. Then this is the sum of the first x digits, which would be the first x, and x is basically the first loop cell in that direction, not including this clued cell itself. Well, it'd be kind of hard to include that because it's not going that way. But basically, in this direction, starting from the cell, this is the sum of the first, whatever this digit is. So say this was a 3, right? Then this digit would have to be the sum of the first 3 digits on the loop in this direction, right? And this digit cannot be larger than the number of loop cells in the indicated direction. So if say it went like this, 3 would not be actually, no, it would not be that. It would have to be like this. If this were like this case, 3 would not be valid because there are not 3 loop cells in this direction. I'm not sure if it applies to something along the lines of, like, say the loop actually went like this. Does this qualify as 3? I don't know. We'll just have to figure this out along the way, if this is valid. I'm guessing it's probably not, but I'm not sure. But I hope that was clear. And so basically, okay, so say as an example here, this was 3, this was 2, and 1. This would have to be 6, because this would be the sum of the first 3 digits on the loop. And actually, I guess we could just use these as, even this is an example, right? This is still 6 because it's still the sum of the first 3 digits, which is 3, 2, and 1 that are on the loop. And that's an example of how these arrow clues work. I think, actually, my suspicion is incorrect, actually. I think you can actually... I think you can actually do something along the lines of this, right? Because it's just counting the first 3 cells that are on the loop in this direction. Because the thing is, the diagonal ones, you're not going to have every cell be necessarily filled here, right? So that could be a little like this, right? For example, here. So this would have to be 2, or it actually could be 1, too, right? But we don't know. It could be 2 or 1 facing this direction, and that I think would be valid. I don't think it forces this to actually be on the loop here. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first thing that I see is I see an arrow here pointing to these 2 cells, right? This has to be different than, essentially, just... We know this has to be a sum, because it's a digit from 1 through 9. Therefore, it also must be the sum of digits on the loop. Oh, and on top of that, it has to be... First of all, it can't be just 1 digit, right? Because if it's 1 digit, it's the same as that 1 digit. and therefore, and they're in the same row in the same box, so that's not going to be allowed by normal Sudoku rules. So this has to be 2 digits, right, that it sees. So these both have to be on the loop. This has to be at least 5 away from 2, but it can't be more, because if we tried to have it more than 2, this would add up to 2 plus 8, which would be 10. So this has to be 9, which makes this a 7. Now this has to get on the loop, and it cannot touch itself. So it cannot go this way. So these are not on the loop. It has to go this way, right? Because otherwise there's no other place. This can't be on the loop because that would touch itself then. So it has to go this way. This, then I guess it could go this way actually. This one's not necessarily off the loop. It could go somewhere here. This has to be a 1. It could go this way, 8 and 3, or the 9 and 3. So either way of these is fine. This has to be at least 6, 8, or 9 here. This cannot be 1, though. So that means we have to have either 2, 3, or 4 cells connecting this way. This one cannot be 1 because again it's the same problem that if it's 1 then the sum would have to be 1 and they would be in the same column. So this has to be at least 2 or 3. We don't know if actually it doesn't have to be, right? This one had to be 2, right? Because there's no way it could be 1. Because even if it's here, that's 1. This would have to be 1, and they would be in the same row. So you would have 2 1s in the same row, and that would have to be a repeat, so that's not allowed. Therefore, this has to be 2. But the first digit on this loop here doesn't have to appear here, right? It could be any one after. This we need to find either 1 or 2. If it's 1, it could be here or here. If it's 2, it could be here or here. If it's 3, it has to be here. I'm going to mark the ones that are not on the loop as pink. And I'm going to mark the lows as blue and the highs as red. So on a loop, you'll know, and especially because it's a German whisper loop, you know it alternates between highs and lows on a German whisper line, right? Because 1 through 4 has to be next through 6 through 9, because if you take the lowest of 1 through 4, which is 1, you add 5 or more to it, you get 6 plus, 6 or more. So therefore, if you have a 1 through 4, you always must be next to a 6 through 9. And it's the same thing. If you have a 6 through 9, you always must be next to a 1 through 4. Because if you take 9, you subtract 5 or more from it, you have 4 or less. So you'll always have a low, a high, and then a low. And then it'll always alternate on the German whisper loop. So and also if you know that's a loop, you know it follows a checkerboard pattern to basically go to be essentially if it's on the loop, it has to follow a checkerboard pattern. And what I mean by that is, say we knew that this cell was on the loop, right? It always has to go low, high onto that loop. So you know that loop cell would have to be a certain value. So in this case, it would be low, high, low, high, low, high, low, high, low. So that would always have to be a low if it were on the loop. Similarly, this would always have to be a low if it were on the loop, because any way you get to it, however you get to it, it would have to well, actually, you can't. Well, it could be on the loop. Hard to say. I realized I didn't explain well how the loop works on anyway on the touching diagonally, but I tried to give an example where that worked. Anyways, if that's the case, since we know it's on the loop, we know it'll follow a checkerboard pattern to where things can be, right? So these can only be lows here if they're on the loop. And that's a key thing. If they're on the loop, these are low. Okay, that actually is helpful. So these are lows if they're on the loop. Well, 4 is a low, but it's not in one of the places where it would be on the loop. So this is not on the loop here. Actually, maybe we'll just make it gray. That makes it easier. It's harder to see in various instances, but... So, it could be something along the lines for here as a sum of various digits. This is a low if it's on the loop. We don't know. This is a low if it's on the loop. So this will see all the digits that are low. This will see all digits that are low. This will not necessarily. One thing is, though, if it goes down, it cannot dip in and then go back out without being more than 2 digits. And it can't be 1. So it can't dip in on a high digit here. It has to dip in on a low digit because it has to be at most 3 digits that sum up to this value, because this value is a digit. You would need double digits to add 4 or more, but you can have 3 that add up to, for example, 8. So actually, it does actually have to be something along the lines of like going here, then going back out, and then going back in, right? Because if you do have something along the lines of going 2 and then another digit, it always adds up to at least 9, right? You have 2 and 7, right, as the perfect example. But we know this digit can't be 9. So it has to be like essentially dip. So that means, and how's the only way you can do that, right? You Every other way of essentially going in, right? If you try to go in here, even if it's on a low, and you try to exit out that way, it will always get a low with a high here. And that's at minimum 2 and 7 because we can't have 1, right? Because if it's 1, then this digit would have to be 1, and then you'd have 2 ones in the same column. So basically, it has to come out. It can't be going in and then coming out this way for the first couple digits. It essentially has to leave and then come back in to get the lowest amount of digits. Therefore, and the only way it can do that is if it comes from this way. So this has to be on the loop. So this is on the loop, this is on the loop, and therefore this cannot be on the loop. So it must go out, which means it goes that way. This then has to be 2 or 3, which makes this 7, 8, or 9. Well, it can't be 7 or 9, so this has to be 8. So I think this almost has to be... Okay, this has to be 2 and 6. Because if you tried to have 3 with 2 other digits, it would have to be 1 and 4. But the problem is we can't exit out here. Once we go back in, we have the same problem, right? Of essentially it has to continue on here, right? So you would have to guarantee a high. So it would be 316 at minimum, which is 10, which is not allowed. So this has to be 2. This is a digit from 7 through 9. It must enter back in on a high digit because it needs 6 to add up to 8. So this is not on the loop. This could be on the loop, but we don't know. So yeah, we've just proven that it does have to go something like this, right? On the loop. This will exit this way, so this is not on the loop, which means this has to be on the loop, this is on the loop, and this is on the loop. Cannot go this way because that would then touch itself, so this has to be on the loop. This can't be 8 because we already have an 8 in the box. This sees 2 unique digits on a German whisper loop, so this must be 7 or 9 also. This will see 2 unique digits, and on top of that, one of them has to be at least 3. So this cannot be 7, this has to be 9, which makes this a 7. Well, if we tried going this way on the German whisper loop, this would have to be at least 3, and 3 is not 5 away from 7, so this cannot be on the loop. So it goes down here. So this is 1 or 2 here. This sees 2 unique digits on a German whisper loop. This sees 2 unique digits on a German whisper loop. Therefore, it's 1 and 3. This can be 6, 7, or 8 because it cannot be 9. If we tried going this way, then this would be a 4, and it would be next to 2 unique digits on a German whisper loop. So this is not allowed. Therefore, it must go down. This is not on the loop. This has to be 1, 3, and it cannot be 4 because it sees 2 unique digits on the German whisper loop. It cannot go this way because then this would be 6, right? And it would be see 2 unique digits on a German whisper loop. So this is not allowed. This has to go this way then. And it could be 8 or 9. I'm gonna actually change all these to not blue because it's kind of confusing. We're gonna make the ones that could be the low ones essentially let's make them orange, I guess. So these are possible lows, right? The blues are the ones we know have to be on the loop, but we don't know about these. So it either goes here as a 6 or here. Okay, and if it tried to go in here as a 6, the problem is it touches itself on its way out. Right? Because it cannot go this way because it's blocked by the rest of the loop. And if it tries going out this way, it will touch itself. So this does have to be on the loop, which means this has to be on the loop. So this must be a 6, which makes this a 1, which makes that a 2, because 6 can only be next to 1 on a German whisper line. This has to be on the loop, and it's 1. So this is 1, which makes that 3, which makes that 1. That's 3 in the corner. We celebrate. I'm not sure why we're celebrating, but we're celebrating anyways. It's 4, 5, and 6 here as for the rest of the box. This could go something like that. This cannot go this way because it touches itself then. So this is not on the loop. It has to go here. This is a high, which makes this 7 or 9. This cannot be 1 because of the 1 in the row. So this cannot be the first cell that it sees on the loop. That means it has to be either 3 or 4 on this loop. Either way, this cannot be on the loop because if it's 3, if the sum of the first 3 digits on the loop, that would mean this has to add up to 5. And that's already not a low. So this cannot be on the loop because there would have to be a low on the loop. So this is not on the loop, which forces this to be on the loop. And this is 3 or 4. So this is at least 5. It could be 5. Not 6. It could... Yeah, it can't be 6 because if it's 4... If it's 4, it would have to be 1, 1... It would be 3, 1, 1 at minimum. So if this is 4, this would have to be 3, 1, and 1. Which would mean that it's 9. So this would be 9, but then this 4 would force that to be 9, because 4 can only be next to 9 on a German whisper loop. So that's not allowed. So this has to be 3. And this is either, if this is 3, this could be 4 on the loop. No, because then it would touch itself. So this cannot be on the loop because it would touch itself. And we still need this part to be part of the loop. Therefore, this is not on the loop. Therefore, this is a 5. So this is 5 to add up to 3, 1, and 1. This is on the loop, and it's a high. This cannot be on the loop because, again, it cannot touch itself. Same here. This can't touch itself on the loop. This has to be an 8 because it's between 2 and 1, and we already have 7 and 9 taken. If the loop were trying to go this way through here, this would have to be a high, so it would have to be 6. And the 6 would then be between 2 unique digits on a German whisper loop. So this cannot be on the loop, which means this has to be on the loop. And it has to go this way. So this is not on the loop. This is on the loop, so this has to be 3, because it can't be 1, 2, or 4. Therefore, that forces this to be 9 and this to be 8. This is 3, so this can't be 3. This has to be 1. So this could still be 6 here. And this adds up to 2 unique digits. So it's saying the first 2 digits, which would be 2 and 2. And therefore, this would be a 4. But this could still be on the loop, technically. This is not on the loop. I guess it could... No, that can't be 1. That's interesting. How does that work? It can't be 3 here. Right? But it can't be 3 here. Because we've already gotten 1, 3, and whatever on the loop. This is problematic right now. How did we know it couldn't go that way? Oh, because it would have to be... Oh, it could have been 2. I think I messed that up. Hold up. It could be 2. That was... Yeah, I think that was a mistake there. So this does go this way, but I think, yeah. The blues... So these 2 are on the loop, for sure. These we know are on the loop. And it can go this way, actually. I think we just showed it cannot go this way. Well, okay. Yeah, there has to be something on this loop here. This is 1 or 3. This is 4, 5, and 6. So this is still the same. But if we only have 3 here, the problem is this becomes a weird thing because it will touch itself on the loop. So it cannot be both of these. So if this is the only way this could work, and this can't be 1. So it can't just be 1 here. It can't be 2 ever in any of these 3 cells. So it always has to be 3 at least, right? Well, if that's the case, this cannot be part of the loop. That means both of these have to be part of the loop, right? If this is 3, these have to be part of the loop. If this is the 3, this can't be part of the loop because it would touch itself on the loop. But then these could connect, actually. Right? Because we know this can't be part of the loop, so it would essentially touch itself here. Therefore, both of these have to be on the loop. And one of these is a 3, right? So it could go something like, so therefore, since it's here, that means this is not on the loop. Because it has to go this way. And this could be on the loop, I guess. It just has to go to one of these. So this is actually not on the loop. This has to be a 2. Can't be 4. Because you'll see 2 unique digits on the loop. And that's where I messed up. Instead of saying this is 4, it could actually be 2 also. Because we know this is a 1-3-1-3 pair here. Yeah, this part still works. So this has to be the part of the loop, which means it connects here and here. This has to be 6 then, which makes this 1 and 1, so that's 2. This is 3, this is 1. This can't be 6 because it's next to a 1 and a 2. And again, it cannot go back here because it touches itself that way. So it has to exit here. If we try, well, this one we still don't have that information. So this is 7 or 9 here. This is 2. Has to be sum of at least 3. Cannot be 4. So it's 3. This could be 1 or 3. It cannot. It could be. It actually could be 4. Whatever it is 2, 1, and 3 at least. So this is 6, 7, 8, or 9. So this is not on the loop. Because it would have to be a low if it were on the loop. Therefore, this loop goes this way, which means this is a low, which means this has to be 3. Because it must add up with 3 digits. Therefore, this has to be 8 or 9 here. This is on the loop. This is not on the loop because it would be touching itself then, if that were the case. So it cannot go this way then. That means this cell has to connect to here. Because it cannot go, it would have to be some weird, yeah, it can't even touch itself that way. So this is always on the loop. Which means none of these 2 are on the loop. This is not on the loop because it must connect that way. And then one of these 2 is on the loop. So this could be 1, 3, or 4. And that would work. It cannot go this way because then this would be high and would have to be a 6. So this is not allowed. This has to be on the loop. And it cannot be a 9. So therefore this can't be 4. Therefore this can't be 9 here. This is 6 or 8, which is 3 plus 1 plus 2, or 3 plus 3 plus 2. This is 7 or 8 because of that's the only digit that can be between 2 other digits on the German whisper loop. That C itself. These have to be 4, 5, and 6, which makes this 3 and 8. This can't be 3, so this is 8, which makes that a 3. The rest of this is 4, 5, 6, and 9. The rest of these are 1, 3 with 4, 5, or 6. This cannot be on the loop because if it were on the loop, it would come here and then come back out and touch itself. So this is not on the loop, which means this can't be on the loop either. This is 3, this is 3. This cannot be 4 because at minimum it has to be 3, 1, and 1. So this is at least 5. But 6 doesn't work either. So this is 5 or 9 here. And it could start being 3 here, or it could start with 4 being here and then this being 3. Either way, this has to be on the loop. And since this is on the loop, this can never be on the loop because it touches these diagonally, so it must connect with both of them orthogonally. Otherwise, the loop would be touching itself. So, and therefore it has to go this way. Because otherwise, if it goes this way, it would branch, which is not allowed. So this has to be 3. This is 3. These are not on the loop. These are not on the loop. This would have to be an 8, 9 pair here, because 3 can only be next to 8 and 9 on the loop. This has to be a 5, which means none of these can be 5. This can't be 5, and this can't be 5. We have an 8, 9 pair here. This is 3, 1. And, well, this one actually could go this way because 8 is not, we don't know where 8 is on the loop. This, no matter where it goes, okay, well, it can't go this way because one of these is 8 or 9. So if it tries going this way, this would have to be an 8 or 9 to be next to a 3 on the German whisper loop, but it's not allowed because we have the 8, 9 pair in the row. So it has to go this way, and it has to be next to an 8 or a 9. Well, we have an 8, 9, 8, 9 pair in box 6, which eliminates 8 and 9 in the rest of the box. Therefore, this is 6, which makes this a 1. So this can't be 1 here. It cannot go down here in the loop because then it would touch itself. So these cannot be on the loop. This is the sum of 3, 2, and 2. So this has to be 7, which makes this 8, which makes that 7. If this continues down this way, this would have to be a 4 because it cannot be 2, 3, or 1 here. But the problem is this 4 would definitely be next to 2 unique digits on a German whisper loop. So this is not allowed to be on the loop, which makes this on the loop. And this is low. It could be 1, 2, or 4 does not work because that can't be 4. This is not on the loop then. Technically, it could go this way. Technically. So I think all the arrows are done, and it's just basically drawing the rest of the loop in. Yeah, because this is 6, which is 3, 1, 2. This is 9, which is 2, 7. This is 5, which is 3, 1, 1. This is 8, which is 2 and 6, and 7, which is 3, 2, and 2. The rest of these digits have to be 4, 5, and 7. And this can't be 7, obviously. This is 4, 5, 7, 9. So if it goes down here, this would have to be a 4 then. So, but then this digit would have to be not 9, because this would be already 9. So the 4 would be between two unique digits on a German whisper loop, which is not allowed. So this cannot be on the loop, which means this does have to be on the loop. It's a 3 or 4, but it can't be 4, so this is 3. It has to be next to a 9 and an 8. This can't be 8 here because of the 8-9 pair in the column, so it has to go down here, which makes this an 8. This has to connect this way, cannot touch itself, and then it has to connect this way. This has to be 2 because it's next to two unique digits on a German whisper loop, and it can't be 1 or 3, so this is 2. This is cannot be 6. It has to be cannot be 7 or 8. It has to be 9 here. It could go this way, which means it would have to go here. So this cannot be 9. This is 4, 5, and 7, but 7 can't be here because one of these two have to be 7. So this is 4, 5, and 6. This is 4, 5, 6, and 7. Not 9, 7. So this can't be 4 here. It could go something like this. Actually, it can't go something like that. So say it tried to go this way. And then it has to, well, it could technically go this way. But then these two would have to both be high. And one of them would have to be a 6. And then they would both be next to two unique digits on a German whisper loop, which is not allowed. So it cannot go this way. Therefore, these are not on the loop. This can't be on the loop because it can't enter there anymore. If we go this way, it's 1 and 2 with an 8 or 9 in between, which is, oh, this can't be 8 or 9. Oh, it cannot go this way because 6 and 7 are taken and 8 or 9 are taken, and this would have to be high if it were on the loop. But none of the high digits are allowed. So this cannot go this way, which means it can't go this way. It has to go here, which means this is a set. It can't be 7, can't be 6. It's 8 or 9 also. Okay. So say we tried to go this way. This would be next to two unique digits on a German whisper loop, so that's not allowed. This would be next to two unique digits on a German whisper loop. So 4 is not allowed. 4 is not allowed specifically. We're looking, and because these are all lows, so if it tried to go here, I guess it could go something like that. So it still could go this way. Can this ever be on the loop? Maybe something like that. So if it goes this way, it's 1. This way then would be 8 or 9 on the loop. Let's fill in the rest of box 4. So it has to be 1, 2, 4, 5, 7. This can't be 2 or 4. 1, 2, 4, 5, 7. 7 cannot be here. Okay, well, we know where the 7 has to be in this box. It has to be here, because none of these can be 7. This can't be 4. It cannot be 4. And this can't be 1. This can't be 4 here. And these can't be 1. So now we have a 2, 4, 5 triplet in box 6, which eliminates 2, 4, and 5 in the rest of the box. Therefore, this must be 1. The rest of these cells have to be 2, 4, 5, and 7. But this can't be 2 or 5. So if this was low, it would go here and have to be a 4, and then it would be next to two unique digits on a German whisper loop, which is not allowed. So this is not on the loop, which forces this to be on the loop. This has to be a 3. because that's the only digit possible now. Because 2, 4, and 5 are not allowed, and this is a low. This has to be 8 or 9, so it could go this way. The rest of these digits are 1. This can't be 7. So this is 1, 4, 5, and 6. This can't be 5. This can't be 1. This can't be 7 anymore, so this is a 4, which makes this 5, which makes that 7. Therefore, this is 4, this is 5. None of these can be 5 here. This can't be 5. Where's the 5 in box 1? It has to be here. These can't be 4 anymore. This has to be a 2, because that's the only place for it in row 5. So now that we can't go this way, I don't think this can ever be on the loop, right? Yeah, it can't, it would touch itself if it tries to go back here. Or if it goes all the way down, the problem is then this would be 8, 9, 8, 9, and this would have to be a 6. But it would see 2 unique digits on the German whisper loop, which is not allowed. So this is never on the loop. This could be on the loop, and this could be on the loop. If this is on the loop, it would have to be a 3. But it could not go this way, because then this would be 8, 3, and then 9. Which is not allowed, because we already have a 9 in the box. So this would have to go this way if that's the case. And it could be 3, 9, 3, 8. So that's possible. Hmm. Okay, what are the remaining digits in column 1? Okay, so this can't be 9. Well, where's the 9 in box 2? It has to be here. That means this has to be 8, which means this has to be 9. So this is still possible. This can't be 4. The remaining digits in column 4 are 1, 3, 4, 5, and 6. But this can't be 3 or 4. This can't be 1. The remaining digits in column 5 are 1, 3, 6, 7, 8. This can't be 1. This can't be 3. This can't be 8. And the remaining digits in column 6 are 2, 4, 5, and 6. But this can't be 4, and this can't be 2. Okay, so if it tried going this way, the problem is it would have to be an 8 or a 9 to be next to it. And none of them could be 8 or 9. So this has to be... It has to go this way, which means this is not on the loop. It has to go this way, which means this is on the loop, so this is a 3. It has to go only this way, which forces this to be 8. And then one of these is 1. We're not sure which. This cannot be 3 here because of the 3 in the column, so this is 6, which makes this 1, which makes this a 7, so this cannot be on the loop, which forces this to be on the loop. And this is not on the loop. So this is our entire loop. This is 1. This can't be 3. This is 2, 4, 5, and 6. One of these is a 4, so this cannot be 4, and this can't be 4. This can't be 1. So we have a 5, 6, 5, 6 pair. Actually, this can't be 6 because of that 6. So therefore, this is 4. This can't be 4 or 6. This must be 3. This 6 means this has to be 4, which makes that a 6, which makes this a 7, this a 4, and this a 6, which makes that a 5. That makes that a 6, which makes that 5, which means none of these can be 5. Well, where's the 4 in column 6? And this is just normal Sudoku. This is 4. This has to be 8 because of this 9, which makes that 9, which makes that 8, which makes that 9. This can't be 6 because of this 6, so this is 2 and 6. The remaining digits in row 7 have to be 7, 8, or 9. This can't be 7 or 9, so this is 8. This can't be 7 or 8, so this is 9, which makes that a 7. Remaining digits in row 8 are 2 and 5. This can't be 2 because of that 2, so this is 5, which makes that 2. This can't be 2 or 5, so this is 4. This can't be 2 or 4, so this is 5. And this makes that a 2. This 5 and 6 means this can't be 5 or 6, so this is 4. This can't be 4 or 5 because of the 4 or 5 in the column, so this is 6, which makes this 5. Therefore, that makes this 6, which makes that 1. And we celebrate with 3 in the corner because we have solved this puzzle. Apologies for that. I don't know why I just completely blanked that 2 could have been here. It did fortunately lead us down to a problematic scenario, so that was good. But yeah, I like these sort of building loop puzzles or constructing region puzzles because the logic behind it is very fascinating behind it. This was fun, actually. A lot of intricate details, but never really that difficult to solve. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.